Hello dear participants of the conference, I'm Miroslav Shigalihin and I want to provide you my presentation. Currently, neural networks are used in many areas. One of the most popular area is in image processing for the finding and classifying various objects. Depending on the goal, the following tasks can be solved using neural networks: semantic segmentation, classification and localization, object detection, instance segmentation. There are many open source tools for implementing these tasks, but firstly you need to create a dataset that will contain labeled images in order to train image detectors based on neural networks. Manually labeling a large dataset is a time-consuming process because in addition to labeling objects, you need to control the correctness of produced labels. The task of detecting a car license plate on an image is not new. There are many open source projects that solve this task. To summarize, the existing methods can be divided into two groups: with using neural networks and without using neural networks. Using neural networks for image processing is a stable trend of last time. Neural networks show higher effectiveness in solving many image processing problems than other algorithms. Most modern neural network architectures for image processing are based on convolution layers, which are the main element of feature extraction from the image. Convolutional networks solve the problem of detecting objects only for images with fixed size that is equal to the size of the input layer of the neural network. Therefore, on the basis of convolutional neural network, image detectors are built. Detectors are differed by the approach of the regions of interest selection and the way of forming the detection area. Currently, the most popular are family of RCNN detectors, YOLO detectors and SSD detectors. We need to choose a detector that will be used for the license plate detection. The most suitable for this task are the one-stage detectors, YOLO and SSD. They don't use a separate algorithm to determine the regions of interest. This increases the rate of the detector. We choose the YOLO detector from the specified pair of detectors because it has more flexible parameters. In particular, the ability to adjust the size of entry boxes for the size of objects of interest. To create data set, we have collected 7,749 images with the cars that have car license plates. Images of cars are represented by various stands. The images were captured from different angles and different camera mounting heights and distance. 1,489 images from this set were manually labeled. The first iteration of the YOLO detector training was performed then. This is an example from training set. The collected number of training samples was not enough for high-quality training of the YOLO model. The results of testing the model after the first training are shown in this table. This is a false positive example. Then we trained the cascade from the OpenCV library to increase the number of labeled images on the initial set. Contrary instances are required to train the cascade. That is, images that don't contain detectable objects. The sample of contrary instance contain 1,268 images of various inscriptions, signboards, and so on. After training the HAR cascade, all 7,749 source images were processed by the resulting detector. The results of the Hoare cascade are shown in this table. Therefore, the number of labeled dataset increased by more than 3.6 times. The sample formed in this way was split into training and test set. The training set included 3,233 labeled images, training set 2. The test set included 2,258. The weights of the neural networks were set randomly during training. The training parameters are similar to those specified earlier. The YOLO detector was trained on the training set. The test showed a correct recognition rate of 73.4%. This is nothing was found example. The usage of anchor boxes in the YOLO detector allows adapting the grid superimposed on the feature map to the geometric parameters of object of interest with different classes. This parameter defines the set and the size of predefined boxes. The YOLO detector initially uses entry boxes that optimized for the characteristics of COCO dataset objects. The method of calculating entry boxes involves the analysis and clustering of bounding boxes and of place objects by area and the ratio of width and height. Large areas on the chart define the size of the entry boxes. This slide demonstrates the different size of entry boxes. Training the detector with the new entry boxes improved the result of correctly recognized numbers by 7%, but at the same time the result of false positive increased to 2.7%. The allocated boxes of car plates began to be localized more accurately at the same time. This is a visualization of the result. This is the correct result example. There was a set of images that the cascade could not recognize during the labeling with the Hoare cascade. This set of images was processed by the detector, and the recognized images were added to the training set. This is how the training set 3 was formed. Training the detector on training set 3 allowed us to increase the result of the detected license plate. However, the result of false positives has also increased. Analysis of the training of the remaining images without labels showed that the dataset mostly contains images with license plates that are located at an angle of more 30 degrees of the horizontal or polluted and so on. These images were labeled manually. Some of them were added to the training set 4 was formed, and some were made up for a difficult test sample with a size of 1,217 images. We calculated entry boxes for the updated training set and the retraining detector. So we got 3 test sets. One test set is a simple set, the second is a difficult set, the third was a mixed set. Thus we improved the model accuracy from the initial 55.4% to 85.9% by transforming input data and training parameters. Using automatically labeled images as training data allowed us to improve the quality of recognition. Thank you for your attention.